We humans, we want to build, we want to construct. That's cool. Also not so cool, because building and construction is one of the highest emitters of greenhouse gases in the world. That's why we did this YouTube channel called Reconstructing the World. My name is Anders Morgenthaler, and right now I'm going to take you through building process reconstructed with Anders Linnaeus, one of the most sustainable architecture in the world. This is Anders Linnaeus, the most sustainable architect in the world. He built this, also this one, and also this one. Actually, he built tons of stuff. Always trying to upcycle old materials to new ones. Because Anders believed that using waste to resources is the only way to reconstructing the world. And for the next year, we're gonna follow the construction of this baby. One material at a time that Anders and his team came up with. It's gonna be super exciting. Hey Andy.
Hello.
We're
Andy.
back, Anders and Anders. And what material are we looking at today, Anders?
We're going to look at one of the most exciting materials on this wood high-rise building. And it's a little bit odd, the material we're going to look at today. It's actually made out of windmill wings.
No.
Yes.
I actually sound surprised, right? I actually knew, but I sound surprised. So, where is it? Is it this one? No.
It's actually on this side of the building here, but it's covered everywhere. But here in the model, it's these pieces which is actually solar shading for all of the windows. And it's really exciting because right now and today, we are creating so much waste out of old windmill wings, and we don't know what to do with them.
But why do we need solar shading here? Isn't solar shading normally something that goes down, up and down, or is
Exactly.
Okay.
And that's the problem.
Okay, you sound exactly.
Yeah, that's exactly the problem. That normally we have a motor, an engine, we have textile or wood or something like that that can move in front of the window and cover for the sun. So the sun goes basically from here and then all the way around the building over to this side.
Okay.
And using a material that is normally just waste is a really good idea to save CO2 and find solutions for something that is a huge problem all over the world, not only in Denmark.
But if it's not moving, why did you go from having something that was moving to a fixed kind of? I guess it's fixed, right?
It's fixed. That's right. Well, the idea here is that if it has the right size and geometry and it's placed the right place in the building, then it can be a static solar shading. And maintenance of buildings where you have mechanical movements and engines causes a lot of extra materials, restoration of these mechanical moving parts. And this is just a static part.
Okay,
so there's an idea in that as well. And of course, we don't have it on the south side, where it doesn't make sense, but we have it on east to west side.
Why doesn't it make sense on the south side?
Because the sun is just hitting directly in here, so it doesn't make as much sense. And so today the material we're going to look at is probably one of the most sophisticated upcycled products that I've tried to work with, because it burns really easy. There's no data of using fiberglass.
It burns really easy.
It burns really easy.
We're going to go back to that one later.
And this is a 80 meters high wood building, and so of course we don't want things that burn really well on a facade like that. So that's what we had to come up with.
Oh shit! I thought you said it burns really easy.
It does.
But you have a wood construction and you have something that burns really easy on the outside.
Yeah. And
we're gonna go into that later in the process when we look at this, because I don't get it.
No.
Let's go to the material room. This is a little too sustainable. Do you consider a handle?
It's an imaginary handle. You have to use your mind to close it.
Okay, great.
Think about it. Yes.
Yes, okay. Okay, welcome to the material room. I'm actually going to try closing the door now. Okay, I actually succeeded. This is a material room, Anders.
Yes.
And this is where we will go through the use of this windmill wing. So let's start with the problem, Anders.
Yeah.
Let's go through the problem that made you investigate how to use windmill wings as a sunscreen.
It all starts almost 5 years ago, where I'm presenting actually for the windmill industry here in Denmark. And I was just curious because everyone, embraces renewable energy in the windmills. So do I. I love them. But then I asked, so what happens when they need to be taken down? Or
The wings or the towers?
The
everything.
whole thing.
Okay.
What happens?
Yeah.
And no one is really saying anything. They're like blah 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 blah.
And
then something like this happens. And the fact of the matter is that there isn't really any solution for the wings, which is fiberglass and balsa wood. And so what to do with them? And since we have so much waste, and what we're seeing here is that we're going to have around 102,000 tons of windmill wing waste within 2025.
this is actual footage of the way they dispose today?
This is how it happens. So it's these mass graves.
Mass graves.
It's bodies, windmill bodies that are put in the ground. It's very, very terrible. They have the same half-time almost as uranium, so it's not going to disappear.
Go through the process here. This is a life cycles of a windmill.
So of course, like the normal kind of value chain is that you're planning to build one, you produce a windmill wing, and it's very complex. You use a lot of resources. Then it's put up and it stands there for 18 years.
18 years, not 25.
Not 25 years.
Okay.
Then, but you put it up and then you use it, and it creates a lot of renewable energy.
Great. We love that.
And that's very good.
Yeah.
And as most people say in average, it's 6 months, then it has earned its CO2 impact, which is right. But we don't calculate the end of life.
No.
So when you take it down, and it's very difficult and complex to get these long wings down, then you have waste. It's cut up in small pieces, and you can burn it, but you need so much energy. Otherwise, you have chemistry and fumes coming out in there. So what to do with them? And then we had to replan that whole value chain of how to do this.
So this is the wing over here, right? He has a wing.
I have a wing. I have a sword, a beautiful sword of a windmill wing.
And just to clarify, this is not an actual windmill wing. This is a model. It's a tiny joke.
Almost 1-to-1. The start of windmill wings.
Okay. So this is a windmill wing.
So when you see the structure and the shape of it, it's one thing is that it's beautiful. It's a complex shape, and that also makes it a little bit difficult to reuse it, because you can say that every part has its own curve or its own geometry.
Okay. Yeah.
So how to reuse it, and then furthermore, when you look into it in the end, not on this one, but this one.
Let's take the big one. I can help.
This one. You got it?
Yeah. This is an actual end of a windmill.
This is the tip of the spear, the tip of the windmill wing. So, as you see, it has kind of a structure inside.
This is one of those that is being transported on the highway?
Yes, this is actually from the first windmill farm in Denmark that was taken down a few years ago, and that was kind of the beginning of looking at this as a potential when you start to cut it down. I mean, isn't it beautiful?
It is actually. I mean, it is actually like a wing on a plane, right?
Yeah.
And you can see the cut through structure here. So so you say, okay, I have this complex form actually.
Yes.
So what do you imagine that what was the thought you had that say, okay, I want to use this material? What part of is usable for what you want?
So that's a good question. So we saw this. Could we see this as a kind of a, if you go to the fish market, they have kind of a drawing about how you would fillet the
great
fish,
comparison. Yeah.
and how you would take it out and use for fillet, or how could we cut it out? And different cuts would create different parts of the building.
Yeah.
And so these places here, we could have long strips that would be quite, the same curve of the wing. If we would cut something out in here, then instead we would have a structural part that could be used for load-bearing structures. It could be used.
What is a load-bearing structure? Just to
the construction, like a column or a beam.
Okay.
That would
so it could
carry the whole.
It could be a wall.
It could be a wall.
Structure.
It could be used. Yes, exactly.
Okay. But you decided to use what part of it?
So we decided to use kind of this part. and cut that out. And we have an example. If you hold that one.
Yeah, I will greatly
Then-
hold
then-
this enormous wing for myself. It's
Then
not
this is
a problem
a
at all.
small part cut out.
And that is from further in. This is not from the tip. This is from one of the big ones.
This is from the beginning of the windmill wing,
Okay.
and so we could cut out a lot of these pieces.
Sorry to interrupt, Anders. I'm just gonna, because it's really annoying. Okay, I also
You can be used
fucked up
for
the
lifting
wall. Sorry,
windmills.
I'm back.
It's a
Sorry.
one rep.
Okay, so this is this the first prototype that you guys did?
Yes.
Okay. Okay, so
Okay.
you were thinking, we have this house, I have this material. Where do you then do a workshop, or do you do a material in this room where you guys come up with, okay, we could use it for this or this or this? Is there a process there?
There's a long process. We hope that we could use it for the whole house, but
As structural beams or?
as facade cladding.
Okay.
That was where we started, and we thought that we knew that this burns really well. So when you have something that burns well, you obviously wouldn't put it on a wood building that's 20 stories high. But how good does it burn? And so some of the first tests we did was like this. And
So that is so what you, just to keep you on track, is that what you do first is you say we have a material, we want to experiment using it either for cladding of the building or something else. The first thing you do is set it on fire.
set it on
Okay,
fire.
so
Burn
and
it.
that's that.
Burn the thing.
Okay.
And here's some of our first tests. This is this.
Did you burn it yourself, or did
Yes.
you burn it on the control?
We had I don't know what that's called in English, but kind of a fire, a point fire. And then we measured the time, how long before it burned. And then it started burning. The interesting thing was that when we got it tested, the people in the fire department came back and said, it burns super well. You're so lucky.
I need to stop you right now. Maybe you guys know this, I don't know, and I'm talking for all the people who don't know. Why are we constantly happy about something burning really quickly on a wooden structure? Please explain why we want it to burn.
There's two situations. One situation is that you don't want it to burn at all. So that's one situation. The other situation is if it burns, you want to have it with as little energy bound in the material as possible. So it almost evaporates.
You want it to burn quickly.
Yes, and when you have a high building, you don't want it to drip or lose things. So fiberglass obviously burns really well, so it almost disappears. So what is left is only kind of the textile after that.
I got some fiberglass in the hand, that's why it's really annoying, sorry. So I did listen to what you said.
It's not a nice material.
I fucking hate it material right now, sorry. So keep talking about that you want
That's
this.
why we put it on buildings. So
it's evaporating on the
hands
outside, and that means that you can then actually save more of the building, and you can get people. The fire department don't need to extinguish the fire over a long time because there's not that much energy bound in the outside. That's
yes.
Okay.
So it kind of evaporates instead of keep burning.
Yeah.
But of course, that's only one part of the truth. One way we had to design with it was also, how much could we use of this material on the cladding?
Yeah. Okay.
And so a part of the building that was interesting to have kind of separated was solar shading.
Yeah, because solar shading today is, as we talked about, is mechanical.
Yeah.
It has a lot of maintenance, and you were thinking, okay, can we do a solar shade that is structural, fixed?
Yeah.
Okay.
So instead of using aluminum or using another material or a composite material, then why not just use something we have?
And you made that one then.
So we made this as a prototype, and this was the first one, a little bit clumsy, but we mounted it and tested it for wind load, how wide it should be, so it would take enough sun.
Yeah. I'm just gonna stop you.
Yeah.
Because I think that we all think about, so we did it. When you do these kind of material development, is it actually just you guys in the workshop cladding this, cutting, sawing, welding yourself?
Yeah, you can just do it. It starts like
How
that.
sustainable?
It starts by just doing it.
Yeah.
So if you can think it, you can probably do it. And then the interesting part in the building industry is that then there's always kind of a standard you have to live up to. So if you know how long it is allowed to not burn, or how long it shouldn't burn, how strong it should be, what wind load it should take, that's all numbers you have to test.
You got the idea of doing a fixed sunshade. You cut out the windmill. You found out, hey, it burns really fucking well.
So that's, yeah, exactly.
And then what happens in the thought process?
Then we have to figure out how to cut up the windmill. So then the important thing is that we have to reinvent the value chain.
Yeah.
So we talk about what do you normally do,
Yeah.
and when you start to see that you can use this for a smart thing, then you have to think about how do we go in, find partners, work together, find someone who can actually help you take down the windmill, start cutting it up and so on.
We left the thing where you said, if you can think it, you can do it.
Yes.
And now, Anders, we're here.
That's so nice.
This is
Fantastic.
Fantastic. This is groundbreaking material, right?
It is groundbreaking. Fantastic.
Yeah. And who's this guy?
It's our best friend, Morten.
Hey guys!
Oh, I didn't know. Hi.
Good to see you.
Hi, best friend.
This guy.
And what does Morten do?
Morten, I can explain just
Please.
a little bit.
Yeah, because he can't talk.
He can't talk.
That's very
yes, yeah.
important.
Morten, he's making windmill wings become a building material, and that is so fantastic and wonderful.
Those
So
over
he's
here.
a magical guy.
Okay. So on the model in Copenhagen, we saw this small thing on the model.
Yes.
Morten is not that small anymore.
No, these comes out of 63-meter long wind turbine blades. But when they are dead, they are a huge issue because this material doesn't degrade.
Yeah.
And it's quite difficult to do anything about. So right now they're just laying, and we have gotten 3 wings that we are now cutting into pieces.
Is this one wing being cut in?
This is
in
actually
various
just a third of a wing.
This is kind of the process of cutting it down. So, but what this length actually resembles is the size that you cut down and put in the ground when you have it as landfill.
Okay.
So when this is waste, this is basically the pieces cut through the other way as well,
Yeah.
and then it's just put in the ground.
Yeah.
And here, now we are starting to see that it can become a product, which is quite unique and fantastic.
So you got the idea of saying we need to take these wings, we need to use them as material.
Yeah.
And on Tre, the building we're talking about now,
yeah.
this is sunscreens, right? You can just take it, Morten. It's not live.
It's
You can
someone-
just take the
someone
phone
calling
and,
us.
no
Yeah.
problem. So, guys,
Yes.
now we need to talk about the very concrete business of cutting this up so it's a usable material, right? So first step was cutting this.
Big wing going to small.
Yes.
And the process here is that you have 63-meter wing. It's laying in the other side of Aalborg. Right now we are in Aalborg East.
Okay.
They are in Aalborg West. And out there, the big crane lifts them up. And then first process is to move them through Aalborg. So they are basically taking down all of the lighting poles, I believe you call it, and then driving them on a big truck.
But you don't cut them before?
No, because they're not allowed to be cut at the place that they are stored right now. So
Oh,
big
shit.
wing moved, and then the first thing is to cutting them into these pieces we see here, 5 meter long. That's with a long wire saw that goes around them, and
Yeah.
for 2 hours it cuts one cut.
Okay.
So just as you can see here, that would be 12 hours of cutting, right?
And that's comparing to other types of sunscreens on buildings. You need to take a material that was not made for this and somehow streamline a process that can make this material. Because I can already think if you need to cut it over and you need to transport it through Aalborg, the product is already.
But you have to remember that these things
Yeah.
is actually something that's happening no matter if it's becoming a product or
okay.
not, because
Right.
it's a waste wing.
But it doesn't
so
make it.
so you need to take it down,
Yeah.
And then you have to cut it up and move it, and either you put it as landfill,
Yeah.
and that's also cutting and transporting,
Yeah.
or you incinerate it somewhere in Germany with a really high degree of temperature. So that part is kind of, we have to move it anyways.
Okay.
Now we just move it here, and then we start working with it. So other waste materials, you get paid to take waste and handle it.
Okay. So actually you get money
these
for this,
guys,
Morten.
but these guys are. It costs a lot to get rid of a 60+ meter long windmill wing out of glass fiber,
Okay.
fiberglass. So there's also an economy in that,
Yes.
right?
So Siemens, they prefer giving it to us than needing to pay the other guys to handle the waste. So in that case,
So in
it's
that
a
case,
win-win.
it's both a CO2 reduction, right?
And you-
Because we use this material one more time.
Yes.
That's one thing. And the other thing is, it's also it's not a cost. It's not something that's driving cost up, right?
No, until they are coming here, it's no cost. But then,
Okay.
of course, going from this size
To this
to
thing.
this size,
Okay. Okay.
then we have some brilliant guys cutting. And even though it's not a big piece like this, it still takes time. And that time is, of course, costly on the saw.
And those are the brilliant guys down there.
Those are the brilliant guys that we have told to stop working.
That's the professors
right? Yeah, we
of
stopped
cutting.
them working.
And they're actually surprisingly light when we get them down in these sizes,
Okay.
due to the structure of balsa wood on the inside,
Wow.
and then a thin layer of glass fiber on both sides.
Okay.
Fantastic.
So this
So
is
this is almost like working. Thank you guys. It's like working in wood almost.
Yeah.
because how can I lift it? Yeah. Okay. Not
But you're also
not
known
that
as
light.
Anders is known as being one of the
Yeah,
strongest.
but I don't have
guys.
strong fingers.
No.
I have
You're drawing
weak
cartoons.
fingers. I'm a cartoonist at first. Yeah.
Yeah.
Okay, so and this is we're gonna see the process of cutting this also. It's
Yes.
gonna be super exciting. It's so exciting seeing things being made, man.
But and the cool thing is here that because we did the fire test
yeah,
and we got this approved,
yeah.
then all of a sudden it's, even though it's a bit more expensive to cut this out, it starts to become a product.
Okay.
And I think that's, I mean, seeing this for me for the first time like this in a small production line is fantastic. It's really, really cool.
Yeah, and so now we can talk about cost because this looks very improvised, right? We
Yeah.
can say that loud, right?
And that's the first time we're
Yeah.
doing something,
So
so we are testing.
Everything's
So-
a prototype.
Yeah, I know, but
Yeah.
but that means that this will be a more expensive product than normal sunscreens, right?
Most probably, yes.
So how is it 50% more or is it 2/3 more? What is?
Depends on, of course, what you compare it to. But for now, I would assume it's at least 50%
Okay.
the cost. Yeah.
But
If
if
you-
we were to do it
You
with
hate it when I talk about that things cost more.
No, that's fine. Here it does cost more.
Yeah.
I mean, when you do something, it's a new prototype and
Yeah.
it's an invention. So of course it comes with a price, and we are pushing something that everyone saw as like no solution at all
Yeah.
to the building sector. So that costs. But it is probably twice as expensive as if we have chosen to do an aluminum
Yeah.
facade. But we're also saving 95% CO2 on doing this.
90,
So it's really
95%
and
CO2.
taking care of a huge waste problem. These have been put in the ground. You would dig a hole in the field out there and then put it down and wait for it to, well, it doesn't disappear.
No, stays for 1,000 years.
So it's a landfill product.
So we
it's
can
a-
use it for 1,000 years. That's what you're saying.
it can stay on
If
the
we want
building
to.
for a
It
long
could be
time.
storing it. Okay,
And
so
we're doing an investment, right, for the environment. As
Yeah.
next time we're doing this, we have learned a lot, and this is the first time anybody is doing this. So hopefully
so-
next time it's cheaper.
So Morten, you're an expert in you're from Again.
Yes,
So you're an expert in taking waste materials and making it to products, right?
that's what we do.
Okay. So in your experience, okay, so this is a first. What the next move will, if you streamline the process here, saying, okay, this is a product that people are interested in, they want to bring down their CO2 reduction.
Yes.
Meaning next time what? The price
Next
is
time.
20% more.
Definitely, the price will hopefully be decreased, and hopefully also the application for the product will be another. Right now, I can tell, I'm an engineer myself, I can point at other engineers saying, here we had the issues of safety concerns, that we were not allowed to do anything else but solar screen. Maybe next time it can be a facade element or
Yeah,
a structural element.
Yeah.
And there we have a higher cost of competitive products.
Yes, but and
But
obviously this is the
Structural.
first thing you said.
Yeah.
Well, the first thing we Anna said when we saw it was like, imagine this was a summer house. So you just cut a hole and you make a bathroom in there,
and span a
Storage.
roof in between.
roof, and then you can have like a super light structure. You know,
Yeah.
structure. Just put it down on
Yeah.
what do you call it? Screw
Foundations.
Screw foundation. I love screw foundation.
Yeah, we love them.
Yeah, we don't
I
go
live on
into
a screw foundation.
don't go into joke mode on screw foundation. But I spotted one thing, Morten.
Yes,
Look
What
at the various sizes
beautiful?
over there.
let's go over there.
Yeah.
And that's the beauty of
that
waste,
is not
right?
that is not a consistent material.
No. And that's how it is. Every time we're working with waste,
Yeah.
it's not the same. And
No.
that's something you as a customer should also be
Yeah.
learning to accept that waste
I think it's
is
a
not
very
the same.
important thing you're saying.
What
Is
one
that
thing?
Morten is saying a very important fact is that if you want to take waste and turn it into building materials, normally if I order building materials, it's all the same shape, like the bananas in the supermarket, right?
Yes.
So a big part of changing to the new material is saying they are not the same shape.
Accepting the odd bananas.
Okay.
Yeah.
And these are actually huge difference, right?
And that is of course something that we take up as a challenge because they are to fit together in
Yeah.
a mounting
Yeah.
system. So what we're doing now is measuring them out first of all, and then each mounting is customized to each of the
Oh shit,
products.
that's also expensive.
So that is
Yeah,
right
that,
now.
That
an
is
issue.
where that's actually one of the points where it's
Yeah.
getting more expensive. Because one thing is handling and craning them in, but cutting them out is, you can see there's a simple machine, 2 guys doing, that's not expensive.
No.
But making
Next
a unique mounting system, that's where it's pushing the economy.
But again, if this went
Yeah, that's
into
what they're
big
called.
production, and you had
Yeah.
big production, and it was both facade element
Yeah.
and structural element and sons, and you had like a factory where tons of wings went through, then you can start sorting them out in sizes,
Exactly.
right?
So, but if this was the facade instead of another material,
Yeah.
then it would really be both economically, but also from a sustainability and also from a kind of operational perspective, because
Right.
these can, they can hang like 50 kilometers. No, how far are they? 10 kilometers offshore. And they can handle to be out there, so they're super durable on the facade as a surface material.
Yeah.
So there are some components in this that's interesting for kind of next level.
So
And
next level is
next
saying-
level could be a facade component completely, maybe until like a row house or 2-3 stories.
Yeah.
You could use it there, or as what I think is super interesting, as a main structure in a building.
Yeah.
Because this can take so much load. It's super strong.
Exactly. So there's much more potential for it than just this first cutout.
Thank you.
I mean, we have to do that, Morten.
Hi.
There you go. Hi.
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 Welcome to.
And so, Jonas, the reason why we're here is because this weird character decided that he could use your windmill wings into products.
Yes.
And Jonas, what are you at Siemens Gamesa?
I'm one of the sustainability freaks at our company.
Okay,
so,
great.
Yeah, I'm trying to improve our processes and products for
Okay.
a better world.
So now we know
Fantastic.
we can call you a freak
Yes,
without, because
yes.
you said it
A
yourself.
sustainability freak.
Yes.
Yeah.
That's good.
Okay, but
I like
as a sustainability freak, you have a problem, right?
Yes.
And these guys are the problem,
Yes.
girls.
Yes.
And what is the problem?
So the problem is that the chemistry that we use, so the epoxy, is difficult to dissolve afterwards. So it is composed of multiple materials, and it requires a lot of energy to separate it.
Yeah.
That will deteriorate the value of the materials and drive up the cost. So there's no cost-efficient ways of recycling, reusing the
No.
blades as of
Just,
today.
So this is after it's been sitting
Yeah.
somewhere for a long time.
And just
Yes.
to look at the layers, you can see the layers here. When you say separate, it's like separating milk from coffee when you have mixed those two together,
Yeah,
right?
almost. Yeah. So it's fibers and resin from each other, and then core materials.
And then there's the balsa wood or other types of light material inside. It differs as well, right?
Yeah. So balsa or plastic foam normally. Yeah.
Yeah. So, Anders, how did the process end up at Jonas? But you said you wanted to make facade elements or sun screens.
Well, it started. We heard that this was a problem, and so we thought, okay, let's help the industry if we have a good idea, and in this case, we had to understand the windmill industry, because how old are the windmill wings? How many are there actually? And are we actually seeing that it's who's taking them down? So we found out that there is very few that are actually the waste handlers of windmill wings in Denmark. That's few companies.
Yes.
And then we started to talk with each other, and then we found Jonas.
But I just wanted to, is it that concrete? So you understand there's a waste problem. Then somebody calls Jonas, and say, "Hey, Jonas,
We have
and
an
you're sitting
idea.
in your office saying, I have a waste problem, I don't know what to do."
Yes.
And then what?
So we are always interested in finding solutions to challenge that we have. Anders and the team came basically with a good idea that we could see potential. What we have been working on is recycling the material. Here we are basically recycling the structure, right? So we get functional value, extending the functional value of the blade, and we found that interesting for this project.
And so, so we have established with Morten from Again, the cutting process, and you guys, have you guys invested in this, in the process of doing this?
Only time.
Only time.
Also quite some
no
hours,
cash.
but yeah.
No cash.
So far.
Are you regretting that?
No. I think even the time is a valuable asset in this. It's a complex structure. You need to calculate loads. Also, a lot of the work that again.
I love it when people say that
It's very political.
time is very valuable.
But I would even say.
But I will say that cash is also extremely valuable.
Cash is king.
Just
I think here, one thing I will give is that when we start these innovation processes, there are so many industries that are rather pushing back than inviting in.
Yeah, okay.
So I think just to complement here, Siemens saying, okay, you guys, we know we have a problem.
Yeah.
That's a first thing to know, say yes, and then be willing to look at it. And so the first test we did, because we didn't really know what was in it, was something that Siemens immediately offered us so we could get started. And to handle such a big windmill wing is really expensive. So just to say, it wasn't cash,
also you
but it was
haven't
really
put in the transportation and all that.
That is
That is
cost.
That is cost, Jonas.
so
sorry.
that's
Cash.
also that's cash.
Yeah.
Okay,
True.
but look at this, because we've talked a lot about these sun things. We don't need to talk about that again, because Jonas is very proud of it, of course.
Yes.
And the whole idea of making it into a facade element. But we've been talking about the structure.
Yeah.
This structure, and over here is Aalborg Portland, who builds, we can say it, highly CO2 damaging structures. Right?
This is the two opposites, right?
Yeah.
Windmill, renewable energy, and CO2 emissions.
But Jonas, you can really see this can carry a lot of load, right?
Yes. So these are intended to last for 30 years. What we can see is that it often can last for more, and then you could say then there are not enough functional value to keep having the loads on the wind turbine, but as sunscreen, for example, could be an opportunity. Yeah.
But the bad story, when you say 30 years of lifespan, is that they are taken down before, because we also see many places that it's easier to put a larger windmill in where you already have a permit. So there is also, and then there is increasingly many windmills coming. So it's an exponential growth we talked about. So there is also exponential more waste.
Yes.
So, what do you think is the best solution for this now? We're looking into a time where we have a lot of this. So do you have other kind of ways to go, or is this what we're doing here? Is this really something that we should do more of and scale up and so on?
I think there's two legs to that. What we're doing here is extending, you could say, the functional life, right? I think we should find all the applications. We have the bike shed also, so of course we should maximize the use of that.
Yeah.
And then the second step is, what about then after these 50 years, 100 years in the building, what are we doing with composite waste? There we are relying on mechanical, thermal or chemical processes for recycling there. So I think it has two legs to it. Yeah.
But I think here at the end to talk about that,
it is extremely obvious that this could be carrying tons of loads and building.
Yeah.
And I think that is a process that you guys need to figure out.
Absolutely.
You guys.
We have to do it.
I mean, I see big value. You know how to deal with the building industry. That is not our core. We know how to design blades. And I think that combination here has been a good collaboration, that you know how to apply what we are good at for the building standards, because we should not underestimate the standards out there and the work needed to overcome some of these.
I totally agree.
And again, I need to emphasize to the channel, remember, we don't, sustainability doesn't come by itself. It comes by you calling somebody, getting the idea, calling Jonas being open in his position, saying, let's talk about that.
Calling his boss, saying,
we
have to do this.
I think we need to talk about that a lot on reconstructing the world. This is the thing. People people
create solutions.
Create
together.
solutions. Yeah. And it is very, very simple. You get an idea. You call Jonas. Jonas could have said, fuck you. But Jonas didn't say that. He says,
come on,
I love you.
Yeah.
And therefore he wanted to do this change. I know you don't. Yeah.
And I think another point to this, Anders, which is something we haven't addressed as much in the other innovations, is that this comes from a totally different industry. So often we think that a shoe needs to become a circular shoe or whatever, same industry. Here the windmill wings has to find their solution in a different industry, and that's really interesting. So there's many ways we can find resources, right?
Are you ready?
I'm ready.
1,
2,
2,
3.
3. See you, Jonas!